June 24, 1941. Somewhere behind British lines in the western desert, the steel was supposed to stop bullets. That was the whole point of armor. But when Allied mechanics fired standard rifles at a captured German armored car, they watched rounds punch clean through the sides. 8mm of steel sloped at aggressive angles marketed by German propaganda as battlefield protection was failing against armor-piercing rifle ammunition. The Sd.Kfz 2222, Germany's standard light reconnaissance vehicle, had a vulnerability that would shock every Allied soldier who discovered it. The vehicle itself looked formidable. Angular armor plates formed a distinctive diamond-shaped profile. The open-topped turret mounted a 20mm autoc cannon. With a top speed of 80 km/h, it could appear and disappear across the battlefield faster than most vehicles could react. German crews trusted these machines. They had been told the armor would protect them. What they did not know was that British infantrymen, armed with Lee Enfield rifles firing armor-piercing rounds, could penetrate that protection at ranges exceeding 150 meters. The story of the Sonderkraftfahrzeug 222 does not begin with its failures, but with the political and industrial circumstances that created it. In the aftermath of the Treaty of Versailles, Germany faced severe restrictions on military development. The treaty explicitly forbade the production of tanks, but armored cars existed in a legal gray area. The Reichswehr, and later the Wehrmacht, exploited this loophole. If they could not build tanks, they would design armored cars that could fulfill many of the same reconnaissance and security roles. Throughout the early 1930s, German planners refined their requirements. They needed a vehicle capable of scouting ahead of advancing formations, locating enemy positions, surviving brief contact with infantry, and retreating swiftly in the face of heavier opposition. Speed and mobility took precedence over protection. Doctrine dictated that reconnaissance troops should observe and report, not engage. The Sd.Kfz 222 emerged from these ideas. Built on the modified Horch 801 chassis, featuring four-wheel drive and four-wheel steering, it represented sophisticated engineering for its time. Its sloped armor and open-topped turret gave it a modern profile, while the 20mm Kwk-30 autocannon provided enough firepower to deter light vehicles and infantry. In theory, it was the perfect scout car, fast, agile, and capable of surviving brief encounters. In practice, its limitations would be exposed by the harsh realities of war. The four-wheel steering system allowed the Sd.Kfz 222 to execute remarkably tight turns, an invaluable feature for navigating narrow European streets or reversing quickly under fire. However, training manuals cautioned drivers to engage the four-wheel steering only at speeds below 20 km/h, as higher speeds could cause dangerous instability. From the outside, the vehicle appeared impressively modern for 1937 when production began. The sharply angled armor plates were not aesthetic flourishes, but deliberate design choices intended to maximize the protective value of relatively thin armor through sloping and deflection. German engineers understood that an angled plate could turn a bullet aside where a flat one might fail. The 10-sided, open-topped turret, protected by wire mesh grenade screens, provided excellent visibility for the commander and gunner while keeping overall weight manageable. Armament evolved over the course of production. Early vehicles mounted the 20mm Kwk-30 autocannon paired with a 7.92mm machine gun. The first batches used the MG-13 before switching to the superior MG-34 in 1938, which became standard across the Wehrmacht. In 1942, the autocannon was upgraded to the higher rate of fire Kwk-38, improving effectiveness against light vehicles and low-flying aircraft. The three-man crew operated in cramped conditions. The driver sat low in the front hull, peering through a narrow armored visor, while the commander and gunner were confined to the small turret, its interior scarcely larger than a modern compact car. Despite the lack of comfort, crews generally praised the 222 for its responsive handling, mechanical reliability, and speed. In its intended role as a fast reconnaissance vehicle, it performed admirably, at least on the roads of Europe. The Horch V8 engine, available in both 3.5-liter and 3.8-liter variants, depending on the model, provided adequate power for a vehicle of its class. The 3.5-liter engine in the AUSF produced 75 horsepower, while the later 3.8-liter unit in the AUSF increased output to 90 horsepower. Performance was respectable, but the Sd.Kfz 210-2's critical weakness lay not in its mobility, but in its armor. The earliest 1938 production vehicles featured just 8 mm of rolled homogeneous armor on all surfaces, including the front. To put that in perspective, 8 mm is roughly the thickness of 4 stacked credit cards, protection designed to stop pistol rounds, submachine gun fire, and distant shell fragments. At longer ranges, the sharply angled plates could deflect rifle bullets, but against armor-piercing ammunition fired at close range and perpendicular angles, the protection was wholly inadequate. German engineers recognized this shortcoming and made incremental improvements. Beginning in 1939, mid-production vehicles received 14.5 mm of frontal armor, enough to resist standard rifle fire from the front, though the sides remained at 8 meters. The late production variants introduced from 1942 featured up to 30 mm of frontal armor, a major upgrade, but by then, thousands of earlier models with minimal protection remained in service. Even the improved vehicles retained thin side plates, vulnerable to armor-piercing small arms fire. The 5 mm plating on the belly and engine deck offered only token resistance to shrapnel. These compromises reflected deliberate doctrinal choices. German planners believed that speed and agility would offset thin armor. Reconnaissance vehicles, they reasoned, were not meant to fight. In theory, this trade-off made sense. In practice, the fluid and chaotic nature of modern warfare made avoidance impossible. When reconnaissance units met enemy infantry or light armor, the Sd.Kfz 222's limitations were exposed with brutal clarity. German propaganda emphasized the Sd.Kfz 222's protection. Promotional illustrations showed its sloped armor deflecting bullets, while training films assured crews that their vehicle offered sufficient security for reconnaissance work. The psychological effect was crucial. Soldiers needed to believe their machines could shield them from harm. Otherwise, hesitation would undermine the aggressive tempo that German doctrine demanded. The 222's angular hull projected confidence. The sloped plates and faceted turret looked modern and formidable. The wire mesh grenade screens gave the impression of thoughtful, advanced engineering. German crews believed in their equipment because they had been trained to trust it. That faith sustained them until experience began to erode it. In Poland in September 1939, the Sd.Kfz 222 performed admirably. Polish forces, caught unprepared and equipped largely with outdated weapons, struggled to counter German reconnaissance units. The vehicle's speed and autocannon firepower proved decisive. While Poland fielded some anti-tank rifles, they were few in number, and infantry often lacked armor-piercing ammunition. The 222 raced through the countryside, scouting ahead of advancing columns, striking deep into rear areas, and spreading confusion. Early success seemed to vindicate German confidence in the design. France, in May 1940, offered similar validation. Despite possessing heavier tanks and artillery, French forces were outmaneuvered by German combined arms tactics. The Sd.Kfz 222 excelled in this environment, screening for panzer divisions, probing weak points, and exploiting breakthroughs. Against retreating or disorganized infantry, its speed and light armament were more than sufficient. In the 6-week campaign that followed, the vehicle appeared to fulfill its promise as the perfect reconnaissance machine. German crews returned home convinced that their vehicles were proven combat assets. Senior officers cited the success of early reconnaissance operations as evidence that German technology and doctrine surpassed those of the Western democracies. The Balkan campaign of April 1941 reinforced these beliefs. Yugoslav and Greek forces, equipped largely with weapons from the previous war, could not effectively counter modern German armor. The mountainous terrain favored light, mobile vehicles over heavy tanks, and the Sd.Kfz 222 performed well in these secondary theaters against weaker opposition. By the spring of 1941, German reconnaissance troops had fought and won in 3 campaigns: Poland, France, and the Balkans. Their vehicles had served effectively in each. Crews had no reason to question their equipment or the assumptions behind its design. Then came Africa. The Africa Corps was officially established on 11th January 1941, a German response to Italy's mounting failures in North Africa. General Lieutenant Erwin Rommel, already renowned for his command of the 7th Panzer Division in France, was appointed to lead the force on 11th February. The first elements of the 5th Light Division arrived at Tripoli the same day. Among these advance units were reconnaissance, detachments, Aufklärungsabteilungen, that would serve as the eyes and ears of the Africa Corps. The Reconnaissance Battalion of Krautschützen Bataillon 3 was among the first to disembark in Libya on 14th of February 1941, bringing with it the familiar Sd.Kfz 222. This unit, equipped with Sd.Kfz 222 armored cars, among other vehicles, immediately began deploying into the desert to probe British positions and gather intelligence on enemy dispositions. The 5th Light Division would later be redesignated the 21st Panzer Division on 15th August 1941, a transformation that reflected the growing scale and intensity of German operations in North Africa. The desert presented challenges unlike anything German forces had encountered in Europe. Vast open expanses stretched for hundreds of kilometers with virtually no cover or concealment. Temperatures soared above 50 degrees Celsius during the day and dropped near freezing at night. Fine, abrasive sand infiltrated every mechanism, wearing down moving parts and clogging filters. Supply lines extended across immense distances with almost no infrastructure, making the delivery of fuel, water, and spare parts a constant struggle. For reconnaissance vehicles like the Sd.Kfz 222, the desert offered both advantages and disadvantages. The open terrain allowed crews to exploit the vehicle's speed to its fullest. Visibility extended for kilometers, enabling early detection of enemy movements. The firm sand and gravel surfaces in many areas provided good traction for the four-wheel drive system. But the same openness that favored reconnaissance also imposed grave risks. Once spotted, the 222 had nowhere to hide. There were no forests, no villages, no rolling hills, only the stark horizon and the promise that every movement would draw fire. The vast distances of the North African desert demanded far more fuel than the Sd.Kfz 222's limited tank capacity could provide. Reconnaissance patrols were forced to calculate range meticulously, establishing forward refueling points and coordinating closely with supply convoys. In the early months of the Africa Corps deployment, the Sd.Kfz 222 performed well. British forces, caught off guard by the speed and aggressiveness of German operations, found themselves repeatedly outmaneuvered. German reconnaissance units pushed deep into British rear areas, gathering intelligence on supply depots, headquarters, and troop movements. The 222's speed and agility made it ideal for hit-and-run reconnaissance missions. Crews could dash towards suspected enemy positions, observe from a distance, and withdraw before British forces could organize an effective response. The reconnaissance battalion attached to the 21st Panzer Division operated almost continuously through 1941 and 1942, conducting missions that ranged from simple route reconnaissance to audacious raids on British installations. Photographs from late 1941 show these units in Libya, Sd.Kfz 222s racing across the desert, angular silhouettes etched against the horizon, dust plumes trailing behind. Yet the British were not the same opponents Germany had faced in Europe. They had been fighting in the desert since Italy's entry into the war in June 1940, developing tactics, logistics, and equipment suited to the environment. More importantly, British forces were now well equipped with modern small arms, including rifles capable of firing armor-piercing ammunition. The Western Desert would become a brutal proving ground for German equipment, and the Sd.Kfz 222 would soon be found wanting. British forces began capturing German vehicles almost immediately. The fluid nature of desert warfare, marked by rapid advances and retreats across immense distances, meant that damaged or fuel-depleted vehicles were often abandoned. The first major haul came during Operation Crusader in November 1941. The offensive, launched on 18th November, aimed to relieve the besieged garrison at Tobruk. Confused, fast-moving tank battles erupted around Sd.Kfz as British and German forces clashed in swirling engagements across the desert. On 27th of November, British forces succeeded in reaching Tobruk, breaking the siege. By mid-December, Rommel had withdrawn to El Agheila. In the aftermath of these battles, dozens of German vehicles lay scattered across the Libyan desert. Some had been destroyed by anti-tank fire. Others had simply run out of fuel, their limited range proving inadequate for the vast distances of North Africa. Many more were abandoned during hurried withdrawals. British recovery teams systematically collected what they could find. Among their prizes were several Sd.Kfz Tu-22s in varying states of damage. According to standard procedure, captured enemy vehicles were shipped back to Britain for technical evaluation at the School of Tank Technology, located on Chobham Lane near Chertsey in Surrey. This institution, part of the Military College of Science, served as the primary British center for analyzing captured Axis equipment throughout the war. Joint teams from the Royal Tank Regiment and the Royal Army Ordnance Corps conducted detailed examinations, producing comprehensive reports on each vehicle's capabilities, vulnerabilities, and tactical significance. But while those analyses would take weeks, field commanders in North Africa needed answers immediately. They could not wait months for reports from England. Field commanders needed answers now. What weapons could defeat these German vehicles? What were their weaknesses? How should British infantry and anti-tank units engage them? Mechanics and engineers attached to the 8th Army began conducting informal field tests behind the lines, towing captured vehicles to secure areas for immediate examination. This pattern, rapid field assessment followed by detailed evaluation in Britain, became standard procedure throughout the war. The most famous example was Tiger 131, the German heavy tank captured in Tunisia in April 1943 during fighting near Point 187, also known as Jebel Jaffa. A hit from a British 6-pounder anti-tank gun had jammed the turret, forcing the crew to abandon the vehicle. British engineers quickly inspected it in Tunisia before shipping it to England, where it underwent months of exhaustive testing at Chertsey. The study examined every aspect: armor composition and thickness, gun performance, engine layout, transmission design, and crew ergonomics. Intelligence derived from that single tank profoundly influenced British anti-tank doctrine and future vehicle development. The Sd.Kfz 222s captured in 1941 followed a similar, though less publicized, path. These light reconnaissance vehicles did not attract the same level of strategic attention as a Tiger, but the British approach was methodical. Every captured example was documented, disassembled, and analyzed. Even relatively minor vehicles contributed valuable data on German engineering standards, material quality, and battlefield doctrine. Multiple Sd.Kfz 222s were shipped back to Britain over the course of the war, each contributing to the growing body of intelligence on German reconnaissance vehicles. The first surprise was mechanical quality. The Horch V8 engine was beautifully engineered, with clean castings, precise machining, and impressive reliability. The four-wheel drive system operated smoothly even after exposure to combat damage and desert conditions. The steering mechanism showed particular ingenuity, allowing all four wheels to turn and giving the car a remarkably tight turning radius. German attention to detail was evident everywhere, from the neatness of weld seams to the precision of assembled components. These were clearly the products of a sophisticated industrial base. Then came the armor. Using calipers, British engineers measured each surface carefully and systematically, 8 mm on the sides, 5 mm on the belly and rear deck. The sloped plates did offer a modest increase in effective thickness, but the results were still startling. One sergeant, who had worked as an auto body paneler in Birmingham before the war, remarked that he had seen civilian cars with thicker bodywork. The testing began almost casually. Someone suggested they should simply shoot at the vehicle to see what would happen. They started with small arms, pistols and revolvers, including 9mm rounds from a Webley automatic. The bullets bounced off at all but point-blank range, leaving only shallow dents in the armor plate. The armor performed exactly as designed against pistols. Next, they tried a Sten submachine gun. The 9mm rounds from the Sten also mostly bounced off. though a few perpendicular hits at very close range severely dimpled the plate and caused spalling on the inside. Against pistols and SMGs, the protection did its job. Then someone fetched a Lee Enfield. The standard British infantry rifle, chambered in .303 British, was not designed as an anti-armor weapon. It was intended to engage personnel out to several hundred meters. The standard Mark 7 ball round fired a 174-grain bullet at roughly 2,440 FTS, comparable to other full-power service cartridges of the era, such as the German 7.92mm Mauser or the American 30.06 Springfield. Crucially, however, British forces also carried armor-piercing ammunition for the .303. The W Mark I AP round used a hardened steel core and substantially greater penetration. The proof standard for AP ammunition required that a specified percentage of rounds penetrate 8mm plate at prescribed ranges. It was purpose-built for threats like the light German cars. Mechanics selected a flat, perpendicular section of hull rather than an angled plate, set up at roughly 50 yards, and fired a W Mark I. The round punched clean through. The impact left a neat entry and a ragged exit. Inside, the plate showed clear spalling and deformation. The test made the point brutally clear. At close to moderate ranges, a standard rifle with AP ammunition could defeat the Sd.Kfz. 122's side armor if it hit squarely. That one shot changed how British commanders and troops thought about the vehicle. What had been a psychological edge for German crews, the belief their car was armored, was suddenly revealed as conditional and fragile. In open desert, a spotted 222 could be engaging reconnaissance. Duties 1 minute and a readable casualty. The next if it came within effective range of an enemy rifleman. Armed with AP rounds, the entry hole was neat and round on the outside. The exit hole on the interior was jagged and larger, with fragments of metal peeled back from the impact. Mechanics gathered to examine the damage, running their fingers over the perforated armor. They fired several more rounds at varying angles and distances. At ranges under 100 yards with perpendicular hits, the W Mark I armor-piercing ammunition consistently penetrated the 8mm side plating. At longer ranges or oblique angles, penetration became less consistent. But in typical combat conditions, a British infantryman with AP rounds could defeat the vehicle's armor. The implications spread quickly through the 8th Army. Intelligence officers compiled reports. Tank crews were briefed. Infantry units received updated guidance. The supposedly armored German reconnaissance car could now be engaged effectively by ordinary riflemen. British soldiers no longer needed to wait for anti-tank guns or tank support. A rifleman armed with armor-piercing rounds could disable the vehicle and kill its crew. Further testing confirmed the findings with heavier weapons. The boy's anti-tank rifle, a .55 caliber weapon firing 13.9 x 99.9mm rounds, achieved 23.2mm of penetration at 100 yards, massive overkill against the Sd.Kfz. 222. The 2-pounder anti-tank gun, a 40mm weapon that served as Britain's primary anti-tank armament through much of the Desert Campaign, could penetrate the 222's armor at any practical engagement range. By the end of these trials, it was clear to British forces that the Sd.Kfz 222, formidable in appearance and speed, was in fact highly vulnerable to both infantry small arms with AP rounds and conventional anti-tank weapons. This intelligence would profoundly shape how British troops engaged German reconnaissance. Units in the desert, tank crews were informed that even their coaxial 7.92mm machine guns could penetrate the Sd.Kfz 222's armor at close range, if fire was concentrated on a single spot. This knowledge quickly spread beyond British forces. Commonwealth units from Australia, New Zealand, South Africa, and India received similar briefings, and Free French forces were also informed. As Allied forces expanded, awareness of the 222's thin armor became widespread. Infantry units adjusted tactics accordingly, fundamentally changing how they approached encounters with German reconnaissance vehicles. Soviet forces made similar discoveries independently. On 23 August 1941, the Red Army exhibited a captured Sd.Kfz 221, the smaller predecessor to the 222, near Moscow. On 7 September, a captured Sd.Kfz 222 was transferred to the Gaz factory at Gorky for detailed examination. Gaz chief designer Vitaly Grachev and his engineering team measured dimensions, tested materials, and evaluated design features. Grachev was particularly impressed by the highly faceted armor plates, angled to maximize ricochet. Although Soviet engineers had begun work on a light armored car design on 17 July 1941, the study of the German vehicle influenced the final design. The resulting BA-64, which entered production in April 1942, incorporated a hull loosely modeled on the Sd.Kfz 222, reflecting lessons learned from German engineering while adapting to Soviet production capabilities and operational doctrine. The multifaceted, angled armor plate arrangement of the BA-64 was directly inspired by the German Sd.Kfz 222. However, Soviet engineers learned from German mistakes. The BA-64 featured 9 mm of side armor, slightly thicker than the German vehicle, though still vulnerable to armor-piercing rifle fire. More importantly, Soviet designers recognized that light armored cars were fundamentally vulnerable to modern anti-tank weapons. They accepted these limitations while maximizing production efficiency. The BA-64 was considerably smaller than the Sd.Kfz 222, with a two-man crew instead of three. It weighed only 2.4 tons compared to the German vehicle's 4.8 tons. It was cheaper to manufacture, relying on automotive components from existing Soviet truck and car production. Most significantly, it could be produced in large numbers. The Gaz factory at Gorky built BA-64s on the same assembly lines that produced Gaz-64 Jeeps, sharing components and tooling to accelerate production. Soviet production philosophy differed fundamentally from the German approach. Rather than producing limited numbers of sophisticated vehicles with complex features like four-wheel steering, Soviet factories emphasized vast quantities of simpler vehicles adequate for their intended roles. Approximately 9,110 BA-64 variants were built between 1942 and 1946, including 3,900 original BA-64s from 1942 to 1943 and 5,210 improved BA-64B models from 1943 to 1946. By contrast, fewer than 1,000 Sd.Kfz 222s were manufactured over 6 years. The BA-64 remained in Soviet service until the early to mid-1950s. Long after the Sd.Kfz 222 had been retired from German service, the vehicle was exported to numerous Allied nations, including Poland, Czechoslovakia, China, North Korea, and Yugoslavia, and saw combat in multiple post-war conflicts. Its longevity and widespread distribution stood in stark contrast to the limited production and early obsolescence of its German predecessor. British forces also developed their own light armored cars, including the Daimler and the Humber. Both offered significantly better protection than the Sd.Kfz 222. The Daimler, entering service in 1941, featured 16 mm of side armor and 30 mm on the front, sufficient to stop rifle fire, including armor-piercing rounds at typical combat ranges. It mounted a 2-pounder anti-tank gun, giving it considerably greater lethality against enemy armor than the 20mm autocannon of the German vehicle. These comparable examples highlight the differing national approaches to armored car design. Germany prioritized speed and agility, accepting minimal armor protection. Britain emphasized firepower and adequate protection, even at the cost of some mobility. The Soviet Union focused on mass production and economy, accepting limitations in both protection and sophistication. Combat experience suggested that the British approach was most effective for armored cars operating in contested areas, while the Soviet approach excelled at delivering sufficient numbers of vehicles to units that desperately needed them. American forces entering the Desert War in late 1942 conducted their own testing of captured German vehicles. Ordnance teams approached the task with scientific rigor, performing systematic ballistics tests and compiling detailed technical reports. Their goal was to determine how American weapons would perform against German armor, providing essential tactical intelligence to troops about to face these vehicles in combat. The M103 Springfield rifle, The standard American bolt-action rifle from World War I that remained in service alongside the newer M1 Garand fired the .36 Springfield cartridge. The M2 armor-piercing round, identifiable by its black bullet tip, was specifically designed to defeat light armor. Official specifications required a minimum penetration of 10.67 meters at 100 yards. Field testing documented penetration of up to 12.7 millimeters at the same distance, easily exceeding the 8mm side armor of the Sd.Kfz. 222, the M1 Garand, firing the same .30-06 cartridge in semi-automatic mode, offered identical armor-piercing performance with the added advantage of faster follow-up shots. American infantry could therefore engage German armored cars with confidence using standard-issue rifles loaded with AP rounds, AE, critical advantage for units encountering them for the first time in Tunisia. Testing also evaluated submachine guns and carbines, confirming that while lighter weapons could not reliably penetrate the 222's armor, rifles and dedicated armor-piercing rounds made the vehicle highly vulnerable under typical combat conditions. The Thompson submachine gun, firing the relatively low-powered .45 ACP pistol cartridge, could not penetrate the armor except at point-blank range with multiple hits to the same spot. The M1 carbine, firing the intermediate .30 caliber cartridge, had marginal penetration capability. At close range, under 50 yards, it could occasionally penetrate the thinnest rear armor, but not reliably. These tests confirmed that the 8mm armor provided adequate protection against lighter weapons, but it offered little resistance to full-power rifle cartridges loaded with armor-piercing ammunition. The distinction between standard ball ammunition and AP rounds was critical. Standard rifle ammunition with lead cores could not reliably penetrate 8mm of steel at practical combat ranges. The armor performed as designed against such ammunition. However, armor-piercing rounds with hardened steel cores were specifically developed to defeat light armor. British, American, and Soviet forces all possessed and issued such ammunition to infantry units, particularly those expected to encounter armored vehicles. Distribution varied by unit and situation. Not every soldier carried AP rounds as standard issue, but it was common practice to supply limited quantities to units operating in areas where they might encounter light armored vehicles. Squad leaders, designated marksmen, and anti-tank teams routinely carried AP rounds, and when intelligence indicated the presence of German reconnaissance units, additional ammunition was issued to ensure effectiveness. Impact angle played a crucial role in penetration effectiveness. The Sd.Kfz 222's angular armor maximized obliquity, increasing effective thickness and encouraging ricochets. A bullet striking at a 60-degree or angle from perpendicular had to travel through significantly more steel than the nominal 8mm, which is why German engineers designed the plates at extreme angles. Even armor-piercing rounds could glance off rather than penetrate under such conditions. However, in practical combat, armored cars frequently presented perpendicular or near-perpendicular surfaces to enemy fire. The sides of the vehicle, where the 8mm armor was flattest, were vulnerable whenever the vehicle moved parallel to enemy positions or turned to engage targets. The flat rear deck and rear plates were even more exposed. German crews learned to avoid situations where their sides or rear faced enemy infantry. But in fluid engagements, such exposure was often unavoidable. By late 1942, the Sd.Kfz 222's vulnerability was well documented across multiple armies and theaters. German reconnaissance units operating in the desert, on the Eastern Front, in Italy, and later in France, all faced opponents who understood that rifle fire with armor-piercing ammunition could defeat the vehicle. The writing was on the wall for the 222 in frontline reconnaissance roles. The vehicle that had performed admirably in Poland, France, and the Balkans, where good roads, weaker opposition, and shorter campaigns had masked its limitations, was increasingly obsolete against well-equipped Allied and Soviet forces. The thin armor of the Sd.Kfz 222, perfectly adequate in 1938 against contemporary weapons, had become a fatal liability by 1943, as armor-piercing ammunition became standard issue across Allied armies. German military leadership recognized the problem of inadequate reconnaissance. Vehicle protection by early 1942. Combat. Reports from Africa and the Eastern Front consistently highlighted the vulnerability of the 222 series to enemy fire. Unit commanders requested better protected vehicles, and crew reports detailed incidents where vehicles were lost to rifle fire or light weapons that should not have been capable of defeating armor. The response was the development of the Sd.Kfz 234 series, known as the Puma. This 8-wheeled armored car embodied the protection and firepower that German reconnaissance doctrine should have specified from the outset. The Puma featured 30mm of frontal armor and 14.5mm on the sides and rear, finally providing genuine protection against rifle fire, including armor-piercing ammunition. Its sloped armor maximized effectiveness, allowing it to resist most infantry weapons and many light anti-tank weapons. For the first time, German reconnaissance units were equipped with a vehicle capable of real anti-tank action. The Puma mounted a 50mm or 39 L60 gun, the same weapon, used on later variants of the Panzer III medium tank, giving reconnaissance crews both protection and firepower previously unavailable. In German light armored vehicles, the 8-wheeled configuration of the Sd.Kfz 234 Puma provided excellent cross-country mobility. The vehicle could reach 85 km/h on roads while maintaining reasonable speed over rough terrain. Its 4-man crew operated in significantly more comfortable conditions than the cramped 3-man crew of the Sd.Kfz 222, however. This capable vehicle arrived too late to significantly affect German fortunes. Development and production delays meant the first Pumas did not reach frontline units until late 1943. By that time, Germany was fighting desperately on multiple fronts, with its industrial capacity stretched to the limit. Only slightly more than 100 Pumas had been built by the end of 1943. Production continued through 1944, eventually reaching approximately 400 vehicles before the line shut down in September 1944, as Allied bombing and raw material shortages crippled German industry. 400 vehicles could not replace the hundreds of Sd.Kfz 222s still in service across multiple theaters, nor meet the reconnaissance needs of dozens of German divisions. The Puma, despite being an excellent design that finally balanced protection, mobility, and firepower, appeared in too few numbers and too late to alter the strategic situation. Meanwhile, less capable but more numerous vehicles like the Sd.Kfz 222 remained in frontline service simply because no alternatives existed. Production of the Sd.Kfz 222 itself ended in late 1943, after approximately 990 vehicles had been manufactured between 1937 and 1943. This total included multiple variants with evolving specifications. The earliest vehicles from 1937-1938 represented the baseline. Design: 8mm armor throughout and a 3.5L engine producing 75 horsepower. The mid-production upgrade in 1939 increased frontal armor to 14.5mm while retaining 8mm on the sides. This change reflected growing awareness that the vehicle required better protection, at least from the front, where it was most likely to encounter enemy fire during approach or withdrawal. However, cost and weight considerations prevented upgrading the side armor, leaving the vehicle fundamentally vulnerable. The AB variant, introduced in 1942, represented the most significant upgrade. Frontal armor was increased to 30mm, finally providing genuine protection against rifle fire from the front. A more powerful 3.8L engine delivering 90 horsepower compensated for the additional weight. The faster-firing KWK-38 autocannon replaced the earlier KWK-30, improving performance against aircraft and light-armored targets. Despite these improvements, most vehicles already in service did not receive the upgrade, and the AB variant retained the vulnerable 8mm side armor, which remained susceptible to armor-piercing rifle fire. Related vehicles in the 22 series included the Sd.Kfz 221, a smaller 3-man scout car with similar armor issues, and the Sd.Kfz 223, a radio-equipped command variant carrying additional communications gear but sharing the same vulnerable armor. The Sd.Kfz 260 and 261 were further specialized command vehicles. All shared the fundamental weakness of inadequate side and rear protection. As a result, many Tu-22s were progressively relegated to rear area security duties, convoy escort, anti-partisan operations, and training roles, missions where opposition was less likely to field heavy weapons or sufficient armor-piercing ammunition. In these secondary roles, the vehicle's speed, reliability, and firepower remained assets. The 20mm autocannon was lethal against unarmored vehicles and effective for suppressing infantry, particularly partisans armed with bolt-action rifles and limited ammunition. The 8mm armor could still provide adequate protection in low-threat situations. Some vehicles survived until the end of the war in May 1945, though by that point they were thoroughly obsolete for front-line service. The rapid advances of Allied armies in the West and Soviet forces in the East in 1944-1945 overwhelmed German defensive capabilities. Reconnaissance vehicles, regardless of type, had little impact on the final outcome. What made the Sd.Kfz Tu-122 historically significant was not its combat effectiveness, but what it revealed about military design compromises and the evolution of battlefield technology. The vehicle excelled at nearly everything except the one factor most critical to crew survival. It was fast, capable of 80 km/h on good roads, and maintaining respectable speed on rough terrain. Mechanically, it was reliable when properly maintained, with the Hork engine proving durable under demanding conditions. The vehicle offered excellent visibility, critical for reconnaissance. The commander had clear sight lines from the open-topped turret, though this design also made the crew vulnerable to overhead threats such as grenades and artillery airbursts. The handling characteristics of the Sd.Kfz Tu-22 were highly praised by German crews. The four-wheel steering allowed tight maneuvers and rapid repositioning, while brisk acceleration enabled quick exits from dangerous situations. Its armament was effective for the intended role. The 20mm autocannon, whether the KWK-30 or the later KWK-38 variant, could shred unarmored vehicles and threaten light tanks at close range. The rate of fire allowed sustained suppression of enemy positions. The coaxial machine gun was excellent for engaging infantry and could be fired independently of the main gun. Ammunition stowage, though limited by the vehicle's small size, was adequate for typical reconnaissance missions. If the vehicle had been equipped with 12-15mm of side armor instead of 8mm, it would have been significantly more survivable against rifle fire while retaining most of its mobility advantages. The additional weight would have been manageable and the performance impact modest. However, this upgrade would have pushed the vehicle into a different weight class, requiring a more powerful engine, stronger suspension, and ultimately increasing costs and complexity. This illustrates the fundamental tension in armored vehicle design. Every kilogram of armor adds cost, reduces mobility, increases fuel consumption, stresses the engine, and creates additional maintenance challenges. Designers must balance protection against all other requirements. Sometimes the balance works. Sometimes, as with the Sd.Kfz Tu-22, the balance fails, and soldiers pay the price with their lives. The calculated risk German planners made in the mid-1930s did not pay off. They assumed that speed and mobility would compensate for limited protection, expecting reconnaissance vehicles to operate at standoff distances, observing rather than fighting. They underestimated how often their light armored cars would come under rifle fire at close range. The fluid, chaotic nature of World War II combat, particularly across the vast spaces of Russia and the open terrain of the desert, meant that theoretical doctrine rarely matched reality. British intelligence assessments compiled in 1943 for distribution to Commonwealth forces methodically detailed every weakness of the Sd.Kfz Tu-122. The document specified armor thickness at key points, identified optimal aim locations for various weapons, and provided tactical recommendations for engagement. Tank crews were informed that coaxial machine guns could penetrate the vehicle at close range. Anti-tank gun crews were advised not to waste scarce armor-piercing rounds on armored cars when high-explosive ammunition was sufficient and more readily available. Infantry received particularly detailed guidance, reminding soldiers that their rifles often dismissed as ineffective against armor, could be lethal when loaded with armor-piercing ammunition against German reconnaissance. Vehicles. Recommended engagement ranges, optimal impact angles, and the importance of concentrated fire were all specified in British doctrine. Training incorporated this intelligence, making sure soldiers knew they were not helpless against German armored cars and that effective countermeasures existed. The vulnerability, however, went beyond armor thickness. The open-top turret, while providing excellent visibility, left the crew exposed to overhead threats. Hand grenades, mortar rounds, and artillery airbursts could kill or wound crew members without ever penetrating the hull. The wire mesh screen over the turret mouth offered limited protection against directly lobbed grenades, but could not stop fragments from nearby detonations. The cramped interior exacerbated these risks. With 3 men packed into a space barely larger than a modern compact car, any penetration or severe spalling, where metal flakes break off the inside face of the armor, could wound or kill multiple crewmen. Spall produced secondary projectiles that ricocheted around the confined compartment, multiplying the lethality of even non-penetrating hits. Logistics added further vulnerability. Ammunition stowage was limited by the small hull, so prolonged engagements could quickly deplete a crew's 20mm autocannon and machine gun rounds. Fuel capacity was likewise modest, constraining operational range and forcing risky refuel practices or abandonment when supplies ran short. Taken together, these factors made the Sd.Kfz 222 a capable reconnaissance tool in low-threat environments, but dangerously exposed in contested areas. Once ammunition was expended in a prolonged engagement, the Sd.Kfz 222 was defensively armed only with crew small arms. Its fuel tanks, though protected by thin armor, could be ignited by incendiary rounds or tracers that penetrated the hull. The tires, puncture-resistant by the standards of the era, remained vulnerable to gunfire. A vehicle immobilized by tire damage became a stationary target, negating its primary survival advantage, speed and mobility. Crews facing disabled tires had to either abandon their vehicle or attempt repairs under fire, neither of which was an attractive option when confronting infantry equipped with armor-piercing ammunition. German crews, to their considerable credit, continued performing reconnaissance missions in whatever vehicles were assigned, including the vulnerable Sd.Kfz 222. Many demonstrated extraordinary bravery, aware of the vehicle's limitations yet carrying out orders regardless. Reconnaissance is inherently dangerous work, requiring soldiers to probe enemy positions, gather intelligence, and often risk their lives to provide. Commanders with information critical for larger operations, the Sd.Kfz 222, served throughout the war in multiple theaters despite its vulnerabilities because Germany lacked sufficient replacement vehicles to retire the fleet. Production priorities focused on tanks, assault guns, and other combat vehicles deemed more critical to defensive operations. Reconnaissance vehicles, while important, received lower priority as German industry struggled to replace catastrophic losses on the Eastern Front and to counter Allied strategic bombing. Several examples of the Sd.Kfz 222 survive in museums today, preserved as historical artifacts representing German military technology of the late 1930s and early 1940s. The Weald Foundation maintains an actual Sd.Kfz 222 OSU specimen, the Bovington Tank Museum, the Australian War Memorial, and various other institutions preserve examples of the Sd.Kfz 222 captured during the war. The vehicle at the American Heritage Museum was seized during the Desert Campaign in 1943 and shipped to England for evaluation at Chatsey. Modern visitors examining these preserved vehicles can see the thin armor plates firsthand, gaining an immediate understanding of why Allied soldiers found them vulnerable once they engaged the vehicles with armor-piercing ammunition. Running their hands over the 8mm side plates, visitors experienced the minimal protection firsthand. The angular design and sloped surfaces, which appeared impressive in propaganda photographs, translate into surprisingly thin metal when inspected up close. The Sd.Kfz 222 serves as a cautionary tale in military vehicle design, illustrating the consequences of miscalculating the balance between protection and mobility. It demonstrates how vehicles optimized for early war conditions can quickly become obsolete as weapons technology evolves and enemy tactics adapt. The story also underscores how design decisions made at the drawing board in peacetime can have lethal consequences for soldiers. Years later, when vehicles confront combat, conditions their creators never anticipated. Finally, the history of the Sd.Kfz 222 highlights the importance of battlefield intelligence and inter-allied cooperation. Through careful analysis, captured vehicles inform tactics, weapons development, and training programs, allowing armies to neutralize enemy advantages and adapt to technological challenges. The rapid dissemination of knowledge about the Sd.Kfz 222's vulnerabilities across British, Commonwealth, Soviet, and American forces meant that Allied infantry worldwide understood they possessed effective countermeasures. This intelligence sharing reduced unnecessary casualties and bolstered soldier confidence when facing German reconnaissance units. From a broader historical perspective, the Sd.Kfz 222 exemplifies the technological and industrial competition that defined World War II. Every nation faced the challenge of balancing protection, mobility, firepower, reliability, and cost. Each design represented a compromise, emphasizing certain characteristics while accepting weaknesses in others. The compromises inherent in the Sd.Kfz 222 worked well in the early war period, but failed as the conflict evolved and opponents adapted the vehicle's story continues to inform modern military vehicle design. Current light armored vehicles and infantry fighting vehicles confront similar challenges in balancing protection, mobility, and cost. Modern materials, such as composite and ceramic armor, offer better protection at lower weight than the rolled, homogeneous steel of World War II. Yet the fundamental tension remains. Every kilogram added for protection reduces mobility and increases fuel consumption. Finally, the Sd.Kfz 222 serves as a poignant reminder of the human cost of technological inadequacy. Soldiers relied on vehicles that were innovative and mechanically impressive, but ultimately vulnerable, demonstrating how design decisions made in peacetime can have lethal consequences once tested under the harsh realities of combat. Behind every penetrated armor plate was a crew member who believed their vehicle offered protection. German soldiers climbed into the Sd.Kfz 222, trusting that their nation's engineers and military leadership had provided adequate equipment. Discovering that this trust was misplaced, that their armor could be defeated by ordinary rifle fire, must have been terrifying. When Allied mechanics behind British lines in the desert discovered that rifles loaded with armor-piercing ammunition could penetrate the German armored car, they had uncovered one of the vehicle's lesser-known vulnerabilities. It was not a war-changing revelation. The Sd.Kfz 222 was a reconnaissance vehicle, not a tank, and its presence or absence did not alter strategic situations. Yet, for individual soldiers facing these vehicles, knowing that their rifles were effective weapons rather than useless against armor was profoundly important. It meant they could fight back. It meant they were not helpless. The 8mm of steel that German engineers believed would provide sufficient protection proved barely adequate against the lightest weapons and wholly inadequate against armor-piercing rifle ammunition. That thin armor, tested in controlled conditions and approved through military bureaucracy, failed when confronted with combat realities, bullets arriving from unexpected angles at close range. German crews paid for that engineering miscalculation with their lives. The revelation spread rapidly through Allied forces, and the Sd.Kfz 222, once feared for its speed and firepower, became known simply as another vulnerable target. Not invincible, not even particularly difficult to defeat, just a vehicle with thin armor that could be penetrated by infantry weapons when loaded with the appropriate ammunition. The Emperor had no clothes, and every Allied soldier quickly learned to see through the imposing angular exterior to the fragile reality beneath.